Good evening, everyone. So, welcome to Career Launcher. My name is Naveen, and today we'll continue with our series of CSAT previous year questions. In the last four sessions, we have looked into the QA part of 2024 CSAT. We will today begin with CSAT 2023 QA questions. So, while we solve questions, and if you guys have any doubts, any queries regarding the exam, the pattern, or any solution that you did not understand, or if you want something more, feel free to write in the comment section whatever you need, whatever you require. We'll bring those topics or those types of questions that you want. So let's start. So the first question says a box contains 14 black balls, 20 blue balls, 26 green balls, 28 yellow balls, 38 red balls, and 54 white balls. Consider the following statements. The smallest number n says that any n balls drawn from the box randomly must contain one full group of at least one color is 175. The smallest number m says that any m balls drawn from the box randomly must contain at least one ball of each color is 167. So this question, when you read it for the first time, may be a little confusing because of the way it has been worded. So we need to first of all comprehend this properly. And this particular question is very close to a concept which is known as pigeonhole principle. Okay, so let's see how to solve it. What we have to understand here is, let me give you another example. Suppose we have a class, and in the class, let's say we have got 10 boys, and let's say we have got 15 girls. So the question is, how many students out of these 25 students that exist in this class should I select, should I pick? And remember, it's not a question of probability or permutation and combination. It's a common sense question. So how many minimum students should I pick so that we have at least one boy in that group? So here it goes. If I select one student, can we be sure that that person is a boy? No, that person could be a girl as well. Right? So just randomly selecting one person, and we're not selecting from the types, as in we know how many girls and boys we have. We're not selecting from girls or boys. We are saying randomly if we have the classroom, and suppose I'm a blind person and I can only call out the roll numbers. So the roll numbers are going to be random. So is it like if I call roll number 3, there will be a boy on that roll number? Not necessary. Similarly, if I, let's say, pick 5 roll numbers, right? If we are completely unlucky, so is it a surety that if I pick 5 roll numbers, there is going to be a boy in those 5 roll numbers? Not sure. Maybe, may not be, right? So we will only say yes when we are sure about it. Worst case scenario, even if I pick 15 students from the class, there still may not be even a boy in that group, right? But the moment I pick 16 people, I know that there are 15 girls. When I pick 16 people, let's say all the 15 girls were, girls' roll numbers were called out. The 16th one has to be a boy. So we will say that we need to pick 16 students out of this class so that there is at least one boy, right? Similar logic is supposed to be used in this particular problem. Also, there is another question that can be asked in that example that I've taken of class and boys and girls, is that how many students should I select so that I have all the students of one particular gender, right? So in that case, can I select one student and I will have all the students of that particular gender? No. Suppose if I select a girl and just one person will not take into account all the 15 girls, right? We'll have to pick all 15 then. And if that one person is a boy, then I'll have to select all 10. So I'm saying that even if I pick 10, is it a surety that all 10 are going to be boys? No. So in that case, what I will do is I will be like, if I pick 9 people from here and 14 people from here, as in if I pick overall 23 people, I may not be still sure that all the gender or all the people of the same gender exist there. राइट, वर्स्ट केस सिनेरियो कि एक लड़का छोड़ के सारे लड़कों को रोल कॉल कर लिया. When I roll call all the 9 boys, I do not have all the people of the same gender with me, gender here being male. And if I call all 14 girls, then still I do not have all the girls with me. So 9 plus 14 is 23. 23 स्टूडेंट्स पिक करने के बाद भी कोई गारंटी नहीं है कि सारे लड़के मेरे पास ही 23 में या सारी लड़कियां. But the moment I pick one more, I will definitely be either completing all boys or all girls. Agreed? So let's look at this particular problem using the same POV. A box contains 14 black balls, 20 blue balls, 26 green balls, 28 yellow balls, 38 red balls, and 54 white balls. So we have a total of 26 plus 14 is 40, 40 plus 20, 60, 78, 78 plus 38 plus 54, that is 92, 78 plus 92, it's going to be 180, right? So we have overall 180 balls, right? Now, out of these 180 balls, how many balls shall I pick such that it must contain one full group of at least one color? Forget about the number there. मेरे को एक complete group चाहिए. So what I'm going to do is कि 14 black balls में से I'm saying I'll pick 13 black balls. 20 blue balls में से let's say I pick 19. 26 में I'll pick 25. 28 के केस में 27. 38 के केस में 37. 54 के केस में 53. So basically 180 total balls थे. उसमें से we have removed 6 balls. So we are at 174 balls. So I'm saying in the worst possible scenario, even if I pick 174 balls, I will not have all the balls of the same color present. अगर ब्लू भी है तो एक बचा हुआ है, रेड भी है तो सारे रेड नहीं है मेरे पास, एक रेड कम है, 37 रेड है, right? So even if I pick 174 balls, I will not have any colored balls, all of them with me. But the moment I pick one more, as in when I pick 175 balls, किसी ना किसी का तो एक पिक होगा और वो सारे कलर मेरे पास आ जाएंगे. Only that color, not all the colors, because the question doesn't say all the colors. It says must contain one full group of at least one color. कम से कम एक कलर भी है तो चलेगा, right? So 175 will become the correct answer. So the first is true, it is correct. So answer cannot be BOD. Now we'll have to check for second. Same logic, we will not read M and all that. We will straight away get to the premise. Must contain at least one ball of each color, right? So we will start with the largest. कि भैया 54 balls ले लिए, क्या मेरे पास सारे colors के एक एक ball हो गई होगा? नहीं, maybe all of them are white. Similarly, the next highest is 38, the next highest is 28, the next one is 26, next one is 20, right? So basically we have 180 balls, usme se if we remove 14, so we will have 166. So I'm saying even after I pick 166 balls, I do not have at least one ball of each color. यहाँ पर black 14 black थे ना, मैंने black एक भी नहीं लिया, so that is going to be missing. But the thing is, the moment I pick one more ball, वो black ही pick करना पड़ेगा because I have all the balls of other colors. तो जो बचे हुए 14 है black ही है. The moment I pick one ball, which is the black one, and now if I look, I will have at least one ball of each color, right? So it's going to be 167 balls. So second is also true. So option C becomes our answer. Right? Let's look at the next problem. So we are given plus within a circle operator, and it tells us that 7 sum operator 9 sum operator 10 results in 8. If we take 9, 11, and 30, it results in 11. And if we have 11, 17, and 21, it results in 30. So there is certain type of calculation that is being performed on the left-hand side that generates the right-hand side answer. Right. So what could that be? So how do we get a 10, 9, and 7 that should result in an 8? So if we have 7 plus 10, that is 17. 17 minus 9 is 8. If I do the same thing with the next one, 9 plus 30 is 39. 39 minus 11 is not 11. Right? So there is certain other type of calculation which is not simply addition and subtraction that is happening. What if we take 9 into 10, which is 90, 90 minus 7? It will be 83. No, because if I do the next one, 11 into 30, that's going to be 330. 330 minus 9, it's not going to give us something which is in terms of 11. So the multiplication is also not happening here. Something interesting is happening. When the simple addition, multiplication, the basic operators, when they do not work, so what do we prefer is going unorthodox way. So basically, if we add them, this is going to give us 26. When we add all of this, this is going to give us 20 plus 30, which is 50. If we add all of this, this is going to give us 49, right? Okay. Now, how to get an 8 from 2 and 6? Same logic, how to get, sorry, this is not 11, this is 5. How to get a 5 using 50 and how to get a 13 from 4, 9. So what we see is if we add the digits of 2 and 6, we get an 8. If we add the digits of 5 and 0, we get 5. If we add the digits of 4 and 9, we get 13. So that's exactly the same logic that we are supposed to use here. 23 plus 4 plus 15, this is going to result in 20, 30, 39, and then plus 3, 42. So if we have 42, if we add the digits, it will give us a 6. So basically, sum of the digits is what this question is about. Another problem. Let x be a positive integer such that 7x plus 96 is divisible by x. How many values of x are possible? Since we are told positive integers, so we can't think fractions and decimal points and irrational values, right? We can only think of 1, 2, 3, 4, 5, 6 and those numbers. Now 7x plus 96 is going to be divisible by x, which means 7x by x plus 96 by x. Now 7x is divisible by x, we get a 7. So basically we need to say that 96 should be divisible by x. Now how many factors of 96 do we have? And NOF here stands for number of factors. So we'll have to prime factorize 96, which is 2 to the power 5 into 3 to the power 1, 32 into 3. So number of factors is given as power plus 1 into power plus 1, which will result in 6 into 2, that's 12. Option C. So x can take 1, 2, 3, 4, 6, 8, all the factors of 96. Because 96 is a multiple of x or x is a factor of 96. So x has to be a factor of 96. We have to count the number of factors. Another problem. A number n is formed by writing 9 for 99 times. So we have 9, 9, 9, and so on. 9, 9, 9. This is written 99 times. Question asked is when it is divided by 13, what is the remainder? Right? Now, it uses a rule which states that if you write any digit 6 times, and if you divide it by 13, you get remainder as 0. So basically, I can change this particular problem as groups of 6 nines, and then again groups of 6 nines, and again group of 6 nines. If I continue like this, so if I have 99 times the digit written, group of 6 will make it a multiple of 6. A multiple of 6 closest to 99 is 96 times, right? And since we have 99, so we are left with 3 nines now. Now the thing is, 96 times would mean how many such groups of 6 nines we are going to have. So basically 16 into 6 is 96. So we are saying 16 groups we will have. Each group will contain 9 nines. Sorry, each group will contain 6 nines. So each one is going to give us a remainder of 0. We are left with only 999. So we'll pick only 999 and divide it by 13. So 13 into 7 is 91. So we'll have 89. Then 13 into 6 is 78. 89 minus 78 is 11. So we will get 11 as the answer. So if you do not know this rule that a digit written 6 times when divided by 13, it gives us a remainder of 0, we will most likely not be able to answer this question. Okay, next problem. Each digit of a 9-digit number is 1. So we have 1 written basically 9 times. It is multiplied by itself. So 1, 1, 1, 1, 1, 1, and again 1, 1. What is the sum of the digits of the resulting number? Now, this is going to be a very, very lengthy calculation. So what I'm going to do is I'm going to follow a pattern. I'm going to see a pattern because I cannot directly calculate such a huge one. So what I will do is I'll think of 1 and 1. It gives us a 1. If I write 11 and 11, so 2 ones and 2 ones, it gives me 1, 2, 1. If I take 3 ones and 3 ones, so we will have to multiply this. It will give me 1, 2, 3, 2, 1. If I take 4 ones and multiply, I will be getting 1, 2, 3, 4, 3, 2, 1. So we see a pattern. The number of ones in the number, that's the highest number we go to. We start with 1, we get back to 1. Since there are a total of 9 ones, so basically we will start with 1, it will go up to 9 because there are 9 ones. And then it will keep climbing down and get back to 1. So this is what the product of these two numbers is going to be. Now we are asked to find what is the sum. So we have a 9. Then we can take 8 plus 1 is 9, 7 plus 2 is 9, 6 plus 3 is 9, 5 plus 4 is 9, 4 plus 5 is 9, 3 plus 7 is, 3 plus 6 is 9, 2 plus 7 is 9, 1 plus 8 is 9, right? So we are getting 9s. How many 9s are we getting, right? So we will be getting 9 9s. So this will result in 81. This is the proper solution. But in the exam, how would we know that 111 into 111 will result in 1, 2, 3, 2, 1, or 4 times 1 into 4 times 1 will result in 1, 2, 3, 4, 3, 2, 1? So we can use a different logic because if you pay attention to the options, they are unique. How? Can I say that this number's sum of digits is 9? If the sum of digits of this number is 9, can we say that this number is divisible by 9? The divisibility rule? Or in other words, can we say this number is a multiple of 9? Basically, what I'm saying is if I write down 1 9 times, this will be 9 into something. 9 की table में आएगा. Now 9 into something multiplied by something will always result in a number which has to be a multiple of 9. And a multiple of 9 number, vice versa, will have sum of digits, which should be a multiple of 9. The only option which has a multiple of 9 is 81 here. Right? So if you use common sense and divisibility rule, we may not have to find out the exact value of 9 times 1 into 9 times 1. It gets easier. Next problem. What is the sum of all digits which appear in all the integers from 10 to 100? Now, if you look at the options, there will always be uniqueness here. So what I'm going to do is I'm going to write 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. Right? These are 10 numbers that I'm going to write. Then uske baaju mein I'm going to write 20, 21, 22, 23, and this will continue. It will go up to 29. And this will continue. The last one is going to be from 90, 91, 92, 93, and so on up to 99. And we will have 100. Now, what is the sum of all these numbers, digits? So 1 is written 10 times. So that's 10. And then 1 to 9 is written. Now 1 to 9, it's the sum is going to be 45. Okay, the next one. 2 is written 10 times, so it's going to be 20. The units digit sum doesn't change. If I look at the last one, 9 is written 10 times, so its sum is 90. And then 1 to 9 is written again 45. And if I look at the last one, it's simply 1. Right? Now we are asked to add all of these. So this is going to be, if I take out 10 common, what I see is I will be having 1 plus 2 and so on up to 9. Okay, we are only paying attention to the first term in each bracket. That's it, not 45. 45 nahi likha idhar. And then if we take up 45, 45 le lete hain. So how many times 45 is written there? How many times we will have plus 45? 9 times, because we have 9 columns, we have 10s and 90s. So 45 will be written or added 9 times. And let's not forget that 1. Right? So the sum of numbers from 1 to 9 is 45. Next 45 is written 9 times, so it's 9 into 45, and then we will have a plus 1. So if we add this, this is going to be 45 into 11, and then we will have a plus 1. Am I missing something? 2 is written 10 times, 9 is written. So if I take out 10, we are adding 1 to 9, and sum of numbers from 1 to 9 is 45, right? 45 is written, added 9 times, so that's 45 into 9. Oh, sorry. It should be 19 now. Why am I so wrong? Itna kam kaise aa raha hai? 45 into 19 plus 1. Now, this is, I'm looking at the last digit. 45 into 19 is a number that will end in 5. And if I add 1 to it, our final answer will be a number that will end in 6. So rather than calculating everything, I'll prefer doing this. Only paying attention to the last digit. Right? Next problem. ABCD is a square. So let's draw a square. 1 point each on each of A, B, and CD, and 2 distinct points on each on B, C, and D are chosen. How many distinct triangles can be drawn using any 3 points as vertices out of these 6 points? So I will use a different color so that there is no confusion. Okay. And I'm going to make it symmetrical, but I will definitely name them as P, Q, R, S, T, and U. So the question I asked is, how many different triangles we can form using these red colored 6 points? See, if you look at the options, so it's even number, which means I'll get symmetrical ones, right? So first case that I would like to choose is P is definitely one of the points, right? From the remaining 5 points, if I select any two, I select U, D, Q, R or S. इन पांच में से कोई भी दो select कर लिया, तो I will be getting a triangle, right? There will be 3 points. P is already selected and then 5C2. So this is going to give me 10. P के साथ हमारे पास 10 बन गया. Now, whichever triangle I'm going to get, in that P is definitely there. The other two could be any other letter, right? Case 2, P is out of the equation. There is no P there, okay? If Q is there, and we will have P is not present, okay? Only Q is there. So Q to hoga hi and P is bahar. As in, bina P ke, how many cases we are going to have if we pick Q? So I'm saying if we have Q, so we will have 4 of them. So that's going to give us 4C2. 4C2 is 6. So we will have 6 such triangles. Now, any combination that we take from here, we will have definitely Q there. Upar wale mein P definite tho, right? Now, the next one is case 3. कि भाई अब मैं P और Q दोनों नहीं चाहिए मेरे को, right? In the example, in the first one, P may be alone, Q हो भी सकता है, नहीं भी हो सकता है. Second case में P कभी नहीं होगा, Q होगा ही होगा, right? Third case, when P and Q are not there, let's pick up R. So if I pick up R, there are only 3 of them, right? R is definitely there. From these 3, if I pick 2, I will be getting a total of 3 triangles from there. And let's take case 4. अब क्या है कि P भी नहीं रख रहा, Q भी नहीं रख रहा, R भी नहीं रख रहा, so we will definitely pick S. If we pick S, there are only 2 more points that we have, U and T, right? So we will have only 2C2, that is 1 triangle possible. So if we count the number of triangles here, this is going to give us 10 plus 6 plus 3 plus 1, which is going to be 26 triangles. Okay, so basically we will have 10 triangles on one side, we'll have 10 triangles on the other side. Instead of P, see these are symmetrical, right? P and S. आप start कर सकते थे कि S पक्के से होगा, उसके बाद T बिल्कुल नहीं होगा, उसके बाद Q भी बिल्कुल नहीं होगा, उसके बाद U भी बिल्कुल नहीं होगा. ऐसे करके आप कोई भी letter से शुरू कर सकते हो. It's just not that P is the first letter of English alphabet, or if it is at the top, that's why we have to do this. आप किसी भी letter से शुरू कर सकते हो. Okay. Now, was there any other way apart from making all these cases and solving them? कोई और तरीका था इसको solve करने का? Since we need to figure out how many triangles we are going to have, right? So what I will do is, let me know in the comment section if there is a faster, simpler way of solving this rather than making cases. Okay, comment it and then I'll let you know if you are correct. Okay, next question. 3 of the 5 positive integers, P, Q, R, S, T are even and 2 of them are odd in some order. Consider the following: P plus Q plus R minus S minus T. So basically we are saying if 3 of them are even and 2 of them are odd, and you are simply adding plus and minus between them. So sum of difference, any combination of even numbers will remain even. Sum of 2 odd numbers, difference of 2 odd numbers, anything will remain odd. And will become even. And sum of 2 even numbers will result even. So first one is definitely correct, right? Let's check the next one. 2P it's definitely even. 2R, it's definitely even. 2S, it's definitely even. And we will have Q and T. Plus minus is not our concern. Now, the thing is, maybe the P, see, 2P is even. I'm not saying P is even. So, अब इसके तीन cases हो सकते हैं. Maybe Q and T, they both are even. Maybe Q is even and T is odd. Or maybe Q is also odd and T is also odd. In the first case, the overall, it's going to be even. In the next case, it's going to be odd. In the next case, it's going to be even again. So when it says it's definitely odd, I'm like, nah. तीन पॉसिबिलिटीज है, दो में इवन हो सकता है और एक में ऑड हो सकता है, तो ये तो झूठ है. So option A becomes our answer. Next problem. Consider the following in respect of prime numbers P and composite number C. So P jahan dikhega is prime, C is composite. P plus C divided by P minus C can be even, right? So because it says can, so we have to think of one scenario किसी भी तरीके से जिससे ये हो सके. So let's take P as 5, ठीक है, prime number. C को भी रहने देते हैं. So we are saying 5 plus something divided by 5 minus same thing, and C should be a composite number. ये इससे डिवाइड हो जाना चाहिए, सॉरी ये इवन हो जाना चाहिए. So 5 की जगह एक काम करते हैं, थोड़ा बड़ा लेते हैं, बिकॉज 5 से कम कंपोजिट नंबर थोड़ा सा लिमिटेड हो जाता है, राइट? सो लेट्स टेक P as 11. Okay. So what if we take 10? तो ये इवन नहीं हो रहा है ना. Okay. We have to think of so that it becomes 2 in the denominator. 11 plus 9 is 30, and 11 minus 9 is 2. 30 by 2 is odd. Okay, so we will have to come up with some other case. What if we take 11 plus odd lena hai na? We can't take 3, we can't take 5, we can't take 7. We can only take 9. If you take 13 or more, it's going to be negative. So thoda bada prime number odd ढूंढते हैं. Let's take a 37. क्योंकि अब 37 से नीचे बहुत सारे odd numbers exist करते हैं, right? So if I take 37 plus 21, this is going to be 58. If I take 37 plus 31, this is going to be 68, but denominator is going to be 6. 37 plus 35, this is going to be 68, 60, 72, and 37 minus 35, this is going to be 2, which is 36. Okay, so 37 and 35, agar ye prime composite liya, we can see that it can be even. So first, can be even, this is correct. Now, second one, 2P plus C can be odd. देखो 2P तो even होएगा ही होगा, and if I add an odd number, it can become odd, right? So I have to think of an odd composite number, which is as simple as C being a 9. So yes, it can be odd. This is also correct. So we'll have to check third now. P into C can be odd. Yes, it can be. We just saw if we take both of them to be odd, the product can be odd. So this is also true. So D option becomes our answer. So we can see that in the recent years, especially in the last 2 to 3 years, CSAT level of questions in mathematics, it has increased. They are not our typical, pre-2022 CSAT exams. Okay, so you guys have to make sure that you practice as many as possible. If you guys have anything to ask, feel free to comment, okay, below. Thank you, everyone. Thank you for joining. Please subscribe to the channel if you haven't yet. Like this video and share it with your friends. I'll see you again with another session of previous year paper. Until then, take care.